Welcome to week 4 of remote learning. Our objective this week is to solve quadratic equations. So actually, that's our new material. It's our first thing on our agenda. Your homework this week is you will have a quiz titled Solving Quadratics. It's housed in Canvas as usual, and there's not an access code. And my office hours, just like last week, are from 1 to 2, Monday through Friday. But again, feel free to email me at any time. All right, let's get started. So just some quick review. Think about when we talk about solving an equation. So this is not the first time that we've solved equations this year, but this is the first time that we're going to solve a quadratic equation. So when we solve, we're finding the value of the variable, which in most cases is the letter x, that makes the equation true. So what makes it a true statement? If we think about this graphically, when we solve, we're actually finding the x-intercept. And just a reminder, an x-intercept, the way we find those is we let the y value equal 0. So we're plugging in 0 for y. And so the coordinates of our x-intercept, again, more review, looks like x comma 0. So that's the ordered pair. So therefore, sometimes when we're solving equations, specifically for our quadratic equations, we have to set them equal to 0. So those are just some notes. You might want to jot a few of these down. That will help you in being successful in this lesson. So we're going to start off trying to make some connections to how we solved equations back in our linear unit. And remember, our plan or our process was to get x by itself. So in this question number 1, we have x squared minus 25 equals 0. And if we ask ourselves, and you guys may remember me always saying, let's play the game. What's happening to x? Well, x is being squared, and then we're subtracting 25. And so I would always ask you, what's the last thing you just said? And that would be we subtract 25. So we're going to need to do the opposite of that. And the opposite of subtract 25 is add 25. So step 1, we will add 25 to both sides. So we're left with x squared equals 25. Once again, we ask ourselves what's happening to x, and x is being squared. So we need to undo that. And the opposite of squaring something is taking the square root. And then we've touched on this maybe once or twice this year. When we take the square root of 25, some of you may even put this in your calculator. Hopefully you know this off the top of your head. The square root of 25 is 5. But that's actually only half right. And you may remember me putting a little plus or minus. You may prefer to write it as 5 comma negative 5. So that's just two different ways. And to kind of prove that to you, remember 5 squared means 5 times 5, which would give me 25. If I have negative 5 squared, that's negative 5 times negative 5, and that's still positive 25. So again, we come up with two answers. Again, you can write them separately, or you can write them together, whichever way you prefer. So again, that's just making a connection to the way that we solve linear equations. All right, so here are 3 more examples. It kind of looks like we're doing the odds, so 3, 5, and 7. So I want you to follow that same process of how we solve equations. Again, we're trying to get the x by itself, think through what's happening to x, and then how would I undo it. So at this time, if you'll press pause, work through these questions, and then when you're ready, press play again. Okay, we're going to get started. Again, if you have not finished these questions, please press pause to give yourself time to finish. In question 3, if we ask ourselves what's happening to x, it's being squared, and then we're subtracting 21. So the last thing I said was subtract 21. So to undo that, we will add 21 to both sides. And you might remember we can draw that line if that's helpful to you. So I get x squared equals 121. Once again, what's happening to x? It's being squared. So to undo that, we take the square root of both sides. And remember, the square root of 121 is 11, but also it is negative 11. So again, whichever way you prefer to write it, you could just do the combo plus or minus 11, or you can write it as positive 11 and negative 11. All right, question 5. What's happening to x? Well, it's being squared, then we're multiplying by 2, and then we're subtracting 98. So the last thing we said is subtract 98. So the opposite of that would be to add 98 to both sides. So I'm left with 2x squared equals 98. Again, what's happening to x? We're squaring it, and then we're multiplying by 2. So the last thing I said was multiply by 2, so we're going to need to divide by 2. And I'm going to come back over here. So I'm left with x squared equals 49. And then last but not least, to undo a square, we take the square root. So x equals plus or minus 7, or x equals 7, or negative 7. And then the last one, we have what's happening to x. It's being squared. We're multiplying by 4, and then we're adding 20. The last thing we said was add 20, so we do the opposite, which is subtract 20. So I get 4x squared equals, I believe that gives me 36. Again, what's happening to x? It's being squared and then multiplied by 4. So to undo multiply by 4, we would divide both sides by 4. So then I have x squared equals, and 36 divided by 4, I believe, is 9. And last but not least, to undo the square, we take the square root. So we get x equals plus or minus 3, or you can write x equals 3 and negative 3. I think on your quiz, I wrote them as separate answers instead of doing the plus or minus, but either one is acceptable for your work. So in the 4 examples we've looked at so far, we were solving quadratics, and we use the same process that we use for solving linear equations. So hopefully that's not too big of a jump. But now, I want to go back to question number 1, and I want to show you that we can use factoring to solve this question instead. So remember with factoring, notice I've already drawn in the blocks and the x, but when we see this, because there's only 2 terms, remember we can write that as x squared plus 0x minus 25. Let me slide that over a little bit so we don't run into and remember the top block always gets our x squared, the bottom right hand corner always gets our constant, and then we are wanting to see what multiplies to give us, and in this case we have negative 25x squared. And then we look here at this middle term, and technically there wasn't a middle term, so I wrote it in as 0x. So we have to think of what are our factors of negative 25. And again, I don't stress so much about the negative part. I just list my factors. So I've got 1 and 25, 5 and 5, and trying to find which pair I could get a 0 from, and that would be your 5 and 5, but one of them would have to be negative. So it has a positive 5 and a negative 5. Make sure I put my x's on there. Again, it doesn't matter which one goes in which block, so I'll put a 5x here and a negative 5x there. And then we think about what times what gives us x squared. And that's going to be x times x. We can bring our x over here and our x down below. Finish up the top row. X times what gives me 5x. That's 5. I can put the 5 at the bottom. Moving on to the second row, x times what will give me a negative 5x, and that's negative 5. I can carry that over, and again, that bottom right-hand box is your check box. Is 5 times negative 5, negative 25, and indeed it is. So we have just factored x squared minus 25. Its 2 factors are x plus 5 and x minus 5. And again, we still have an equation here that we need to solve, so we set that equal to 0. And if you think about it, we have 2 things that are being multiplied, x plus 5 times x minus 5, and we're supposed to equal 0. And the only way that we can get 0 when we multiply is that either the x plus 5 has to be 0, or the x minus 5 has to be 0, or they could both be 0. So the way you solve this is you set each of those factors equal to 0. And then you solve, and these are very simple to solve. For the first one, we will subtract 5 from both sides, and we get x equals -5. And the one on the right, if we add 5 to both sides, then we get x equals +5. So if you go back and look at your work, notice we came up with the same answers that we did earlier for question number 1. Some of you might think, oh, that's way too much work. It was much easier to do it the first way, which is fine. But what you will quickly figure out in the next few slides is that not all quadratic equations can be solved using the method that we did for solving linear equations. You will have to use factoring. All right, so let's look at number 3. Could we solve this one through factoring? And if you think back to what I talked about with solving equations in that very first slide, I said that sometimes when we solve a quadratic, because we need it to be equal to 0, because the y is supposed to be 0. So for this question, it becomes a little bit more difficult, but we're going to need to subtract that 100 from both sides. So that gives us -121. And then again, we can write that as x squared plus 0x minus 121 equals 0. We can fill in our x squared. We can fill in our -121. Again, we want to see what multiplies to give us our -121x squared. And then we want to see what adds up to give us 0x. So again, I don't really worry so much with the negative to start with. I have 1 and 121. And then I know I have 11 and 11. Those are the two that pop into my head. And if I'm trying to be able to combine these to get a 0, that helps me to see that I'm going to need to use this second set, but one of these is going to need to be a negative. So a -11 times a +11 will give me that -121. And if we add those together, that will give us a 0. So we have 11x and -11x. Again, doesn't matter which one goes in which block. And then we go back. X times x is what gives us x squared. Thinking back to the barnyard when we had, I think it was the pigs, or it was the ducks, I don't remember. Mr. Woolley was teaching then. Then to finish out the top row, x times what gives us 11x, and that would be 11. We can fill that in the bottom. On the second row, x times what gives us -11x, that's -11. Again, checkbox is 11 times -11, -121, and it is. So my two factors are x plus 11 and x minus 11. And then just like before, we need to set each of those factors equal to 0. Because if they're going to multiply and get 0, that means at least one, possibly both of them, have to be 0. And then we just quickly finish up. Subtract 11 from both sides. So x is -11. Add 11 to both sides. So x is +11. So once again, if you look back, we got the exact same two answers that we did earlier when we solved number 3 using our linear techniques for solving equations. Again, just giving you options of how to solve. All right, for number 6, this one's different. It says 3x squared minus 27 equals 0, and I've specifically told you I want to solve this by factoring. So again, I'm trying to baby step this to kind of transition you into solving by factoring. If you remember from our lesson last week, from week 3, whenever we factor, we should always look for a GCF. So before we get started, if we look at 3x squared minus 27, is there anything they have in common? Well, both of them don't have x's, so we know we're not going to be able to factor out an x. So we need to look at the numbers 3 and 27. And obviously 3's only factors are 1 and 3, so then I think about 27. Is 27 divisible by 3? And it is. So we're going to factor out that 3. And I'm left with x squared minus 9. So 3 is still going to hang out. Remember the x squared minus 9? We can write that as x squared plus 0x minus 9. And then we can go into our factoring. We're going to put the x squared. Again, we're using the piece that is in the parentheses here. We're just looking at this because that's the part that we need to factor. So x squared in our top left-hand corner, our negative 9 here. We want to see what will multiply to give us negative 9x squared. And then I will see what adds up to give me that 0x. So 1 times 9 and 3 times 3. Again, we need a negative 9 and we need to get a 0. So one of those 3's is going to have to be negative. So we've got a 3x and a negative 3x. And then back to our standard factoring. So x times x will give us x squared. We can fill in the right and the bottom. Finish up the first row, x times 3. And fill that in on the bottom. Continue on with row 2. X times, that would have to be a negative 3. Pull that over to the right. And then check 3 times negative 3 is negative 9. So my factors are, again, we still have the 3 out front. And then we have an x plus 3 and an x minus 3. And this is the next part where a lot of students, I guess, kind of make a mistake. When we start setting them equal to 0, again, we're setting the factors, but a lot of kids want to set this 3 equal to 0. But I think we're all aware that 3 does not equal 0. So we're not going to worry with that. The only things that we want to focus on are the actual two factors that contain the x's. So we're going to do x plus 3 equals 0 and x minus 3 equals 0. So we solve each of those, and we get x equals negative 3 and x equals positive 3. Again, you could have solved this one using our linear methods for solving equations, but just trying to reinforce how you can use factoring to solve this as well. Again, to solve this by factoring, we're going to need to set this equal to 0. And so in order to do that, we are going to have to add the 66 to both sides. So I get 5x squared minus 20 equals 0. Again, we're factoring, so we always look for a GCF first. Again, the two terms don't both contain x's, so we look at the numbers. And we have 5 and 20, and those are definitely both divisible by 5. So I can bring out the 5, and I'm left with x squared minus 4 equals 0. And again, because we are factoring and we've already taken out the GCF and we only have 2 terms, I'm going to write that with 3 terms, putting in that 0x. So my x squared is going to go in the upper left, the negative 4 in the bottom right. We want to see what multiplies to give me that negative 4x squared. And what adds up to give me that middle term of 0x. So we've got 1 and 4, 2 and 2. Again, we actually need a negative, so one of those has to be negative, but we got to get a 0, so we can do a negative 2 and a positive 2. So 2x and negative 2x. And you guys hopefully are pros at this by now, so x times x gives us x squared. Fill in the right and below. X times 2 would give me 2x, and then x times negative 2 would give me negative 2x. Again, bottom right hand corner, check. 2 times negative 2 is negative 4. So 5, and my factors are x plus 2 and x minus 2. Again, do not be distracted by the 5 out front. We are solving for x, so we only need to worry with the 2 factors that contain x. X plus 2 equals 0, x minus 2 equals 0. Again, if you tried to set the 5 equal to 0, we know 5 does not equal 0. So then to solve, we can subtract 2 from both sides. and we get x equals -2 as one of our answers. And for the other one, if we add 2 to both sides, we get x equals +2. So still coming up with 2 answers, but solving by factoring. All right, so we've done a lot of these questions that we could solve algebraically through our linear solving methods, but I've been working with doing those by factoring. Again, a lot of times my students get annoyed because they don't want to do these by factoring. They think it's much harder. But again, I'm getting ready to transition to questions that you have to use factoring to solve. So I haven't drawn the blocks for these, but we're just going to start off. Notice these are a little bit different because they have 3 terms. All right, so I'll go ahead and draw my block. Going to fill our x squared, our -3. We're trying to figure out what multiplies to give me a -3x squared. And what adds up to give me a 2x. And so our only options are a 1 and 3 that we can multiply. Granted, it's got to be a -3. So then I have to decide, well, which one gets the negative? Is it the +1? Or excuse me, is it going to be a +1 and a -3 or a -1, a +3? And I see that I want to get a +2. So that means I would have 3 minus 1. So a 3x and a -1x. And again, just look at it and make sure that works. If we multiply them, do we get -3x squared? When we add them, do we get 2x? Again, it doesn't matter which block gets what. Again, these are nice ones that just have the x times x for x squared. So hopefully reinforcing what we've done in the prior 2 weeks of remote learning. Then x times what gives me 3x. Can put that at the bottom. X times what gives me a -1x, so that's where we get a -1. And then check, is 3 times -1 -3? It is. Now remember, we have to solve this. So our 2 factors are x plus 3 and x minus 1. And then we set each of those equal to 0. Because we're multiplying, again, one or both has to be equal to 0. And then to solve, for the first one, we can subtract 3 from both sides. And we get x equals -3. For the second one, we add 1 to both sides, and x equals 1. So came up with 2 different answers, as we have seen in the past. All right, I'm going to draw a line down the middle, kind of separate these a little bit. Again, solve by factoring. So the first thing we look for, is there a GCF? I didn't say that in number 9, but I did look for it. There wasn't anything that all 3 terms were divisible by. But this one only has 2 terms, so I was kind of a little bit more inclined to look for that first. So 10 and 20 are both divisible by 10. And then if you notice, both terms contain an x. So I'm going to factor out a 10x. And when I do that, 10x squared divided by 10x would just be x. And again, you can put a 1 out there if you would like. And then a -20 divided by 10 would give me -2. And x divided by x is 1. So those are, in other words, cancel. Once again, we still have 2 terms. And some kids freak out on these because they don't think of this as 2 terms because they don't see that parentheses. But we do have 2 terms. We have this 10x and we have the x minus 2, or the 1x minus 2. So we set each of those equal to 0. So 10x equals 0 and x minus 2 equals 0. Again, I dropped the 1. Feel free to keep it if you would like. Then to get x by itself, again, this is 10 times x, so we do the opposite, which is divide. Again, if I have $0 and I split it between 10 people, we still have nothing. Over here, we're doing the opposite of subtract 2, which would be add 2. So I get x equals a +2. And again, these 2, we could not solve them using our techniques for linear functions. We have to use factoring. So when we look at number 13, 3x squared plus 13x equals 10. If you recall, we are supposed to make sure that the equation equals 0 before we start. So in order to do that, I need to subtract 10 from both sides. So I have 3x squared plus 13x and then minus 10. Again, we do not have any like terms. We do not have a GCF. So I'm ready to draw my block. And my x. Again, we're looking for what oh, I hadn't filled that in yet. So we're going to fill in the top block is my 3x squared. My bottom right-hand corner is my negative 10. We're seeing what multiplies. In that case would be a negative 30x squared. And then we want to see what adds up to give me 13x. So if we list our factors of 30, again, I'm not going to worry about the negative right now. We've got 1 and 30, 2 and 15. And I could keep going, but I think I just realized that that 2 and 15 will actually give me a 13. But again, I need a positive 13, so I have to decide which one gives me a negative, so that would be a negative 2. So I have a 15x and a negative 2x. Again, if we multiply those, that will give us the negative 30x squared. If we add them, that gives us the positive 13x. So I'm going to fill those in, 15x and negative 2x. And again, these are the ones that are a little bit harder because it's not just plain x squared in the top left-hand corner. We have a 3x squared. And so like last week, if we look at that top row and we want to think about a GCF, so we have to ask ourselves, what do those two terms have in common? Well, if we look first at the numbers, the 3 and the 15, the coefficients, to do some vocab review, those are both divisible by 3. So I can write a 3. And then notice both terms have an x in them. So 3x would be our GCF. And then, like I said, it's kind of like a puzzle. We can put the 3x over here on the right-hand side. Then we ask ourselves, 3x times what gives me 3x squared? And that would be a 1x. If you don't want to write the 1, that's fine. I'm going to put it at the bottom as well. Then we say 3x times what gives me 15x? And so that would be 5. You can fill that in at the bottom. Second row, 1x times what gives me negative 2x? That would be negative 2. Fill that in on the right. And check, 5 times negative 2 is negative 10. So my factors are x plus 5 and 3x minus 2. Again, we're setting each of those equal to 0. I didn't leave myself enough room. And then we solve. So minus 5, minus 5. I'm going to come over here and write my answer. X equals negative 5 is one of my answers. I'll switch colors so you can hopefully follow along a little bit better. To solve the second one, we would need to add 2 to both sides. And that would give us 3x equals 2. And then I would have to divide both sides by 3. So my other answer is 2/3. So two answers, just got a little messy. So let me highlight those. X equals negative 5 and x equals 2/3. So now if we look at number 14, again, we're still solving by factoring. Again, check for a GCF. It's already set equal to 0, so we're good with that. Both of these terms are divisible by 4. So we can factor out a 4. So we get x squared minus 9. And then we can put that 0x in there to hold our place. Come over and draw my block. And my x. So fill in my x squared, my negative 9. And I want to see what multiplies to give me negative 9x squared. And what adds to give me 0x. So we've got 1 and 9, 3 and 3. Again, we need a negative, and it needs to add up to 0, which tells me that one of these 3's will have to be negative. So 3x negative 3x. And this is one of the easier ones. X times x is x squared. X times 3 would give me 3x. Row 2, x times negative 3 would give me negative 3x. And then 3 times negative 3 gives me negative 9. So, again, we still have the 4 out front. And then we have an x plus 3 and an x minus 3. Again, we don't have to worry about the 4 because we know 4 does not equal 0. So we set x plus 3 equal to 0, x minus 3 equal to 0, and we solve each of those. So x equals negative 3 is one answer. X equals positive 3 is the other answer. Again, a lot of work on this page, so I will highlight those. So 3 and negative 3 are the answers to number 14. So we're really not doing that or anything too different from last week. It's just once you factor, then you're going to set each of the factors equal to 0 and solve those separate equations. Okay, for this last example, it's a little bit different. I've left an entire sheet for us to work this, so things shouldn't get too crowded. If you remember from earlier, we said that the equation must equal 0 when we're solving quadratics by factoring. So I'm going to need to bring over that x and that 42. So I can subtract x from both sides and subtract 42 from both sides. So I'm left with x squared minus x minus 42, and then nothing's left on the right-hand side, so that is 0. So I can draw in my block, make my x, fill in my x squared, my negative 42. We're looking for what multiplies to give me negative 42x squared. And we want to add up to this middle term. And that may look a little weird because it just says negative x, but remember there is a 1 in front of that. So a negative 1x. So I start listing off my factors of 42. Granted, I know it's supposed to be negative. So I've got 1 and 42, 6 and 7, and there might be some more, but the 6 and 7 kind of caught my eye because if I put 6 and 7 together, if I subtract, I can get a 1. But notice I need a negative 1. So that would have to be a positive 6 and a negative 7. So a 6x minus 7x would give me that negative 1x. And again, if I multiply those, I get the negative 42x squared. So I'm going to put the 6x in the top block. And the negative 7x on the second row. Again, a nice one. X times x give me x squared. X times 6 will give me 6x. X times negative 7 will give me negative 7x. Checkbox, 6 times negative 7 is negative 42. So my factors are x plus 6 and x minus 7. And then, so now we have to set each of those factors equal to 0 in order to solve. So subtract 6 from both sides. Add 7 to both sides. So our two solutions are negative 6 and 7. All right, so for these questions, it asks you to find the x-intercepts, and it wants you to plug in. What that means as a refresher, you have to plug in 0 for y and then solve. And I made a note here that we are going to have to factor questions 20 and 26. I know these numbers may look kind of strange, but I just took part of some problems from the workbook that we would have been using were we still in school. So we need to replace the y's with 0. So I think I'm going to go through all the problems right now and just on top of that y, put a 0. Just go ahead and take care of that piece. And again, you might want to pause the video to write down these questions. Some of these are actually going to be pretty quick. If we look at question 18, again, we're trying to get the x by itself. We ask ourselves, I'm going to go back to kind of that beginning part. What's happening to x? It's being squared and then multiplied by 9. The last thing we said was multiply by 9, and the opposite of that is divide by 9. And we have 0 divided by 9 is still 0, and we're left with x squared. And then to get the x by itself, it's the opposite of squaring, is taking the square root. And so we will get x equals 0. And you may think, well, we need to put a plus or minus. But remember, 0 is neutral. It's not positive or negative. So this is the one instance where we only have just one answer. It is just 0. We'll go ahead across to 24. Again, not working with the numbers, but we'll go do the first row, second row, and then third row. Again, this is already factored, so these are kind of quicker. Trying to make this not so much work for you guys. I'm going to set each of those factors equal to 0. So I've got my 4x equal to 0, and then I have my 3x minus 15 equals 0. And then we go through our solving, divide both sides by 4. 0 divided by anything is still going to be 0. Over here, we're going to have to add 15 to both sides. So I get 3x equals 15. Run out of room. I'm going to write this one up top. And so 15 divided by 3 will be 5. Again, that got a little messy, so I'll highlight those for you. We got x equals 0 and x equals 5. So for number 19, we have two factors. We set each one equal to 0. Then to solve, we can subtract 5 from both sides. And then to get the x by itself, we will need to divide both sides by 3. So x equals negative 5/3, and it's fine to leave it like that. And then our other answer, we need to solve the second equation. A lot of kids on this one will go ahead and move the 4 to the other side. I'm actually going to move the x over. Again, it doesn't matter. It's just less steps if I do it this way. And so now I have x equals 4. So my two answers for number 19 are negative 5/3 and 4. Number 25, 0 equals 3x minus 8 quantity squared. Again, the opposite of squaring something is taking the square root. So first off, I'm going to go ahead, think through our process, what's happening to x. It's being multiplied by 3, then we subtract 8, then we square it. So to work that in the opposite order, we'll take the square root of both sides to start with. So 0 equals 3x minus 8. Again, we do not have to put a plus or minus since 0 is neutral. We add 8 to both sides. And then lastly, we will divide both sides by 3. So x is 8/3. So again, another question where there is just one answer. All right, for the last two, I want you to press pause, and I want you to work through the factoring of these two. And then once you had factored them and tried to go through that process of solving, press play, and then we will go through. I'm not going to show all the box and the X for these just because I didn't really leave enough room. And again, I've done a lot of factoring today, and you've probably had enough of it. So we'll go through these last two pretty quickly. So press pause now, and then when you're ready to move on, press play. All right, so I'm going to work through 20 and 26. Again, without showing all the work, the two factors that you should have come up with were x plus 3 and x plus 2. So x plus 3 equals 0, x plus 2 equals 0. Then if we subtract 3 from both sides, we get x equals negative 3. And if we subtract 2 from both sides, we get x equals negative 2. And last but not least, For 26, the two factors that you should have come up with are x minus 5 and x plus 1. Set each of those equal to 0. And then when we solve, we get x equals 5 and x equals negative 1. So again, these were nice. The first one, we just had to divide and take the square root of both sides. For the next two, they were already in factored form. 25 was another one where you needed to take square root of both sides, and the last two involve factoring. All right, so now it's time for you to practice. So I want you to solve all of these by factoring. If you pay close attention, don't freak out with 7 and 8. They use a different variable, actually in 10. They use other variables besides the letter x. If that freaks you out, feel free to rewrite them with x's on your paper. That's fine. Pay close attention in number 11. Notice we have this equals negative 5. Remember, it has to be equal to 0. So remember, you're going to have to bring that negative 5 over. Same thing with number 14. We've got this negative 4, so you're going to have to bring that over. For number 12, that one is super tricky. You feel like you want to be like, oh, it's already factored, so I can set them equal, but notice there's a 15 over there. So for this one, you're also going to have to move that 15 over, and you also need to distribute the x, and then that will turn into a factoring question. So do not be deceived. Those are a little tricky. So if you will press pause, work through these questions, and then when you're ready to check your answers, press play, and we'll move on to the next slide. Again, I'm not working these out. I just have the answers posted, and then if you have questions, you will be able to email me, and I'm happy to set up Google Meets and work through any of these that you would like. So at this time, press pause. Okay, hopefully by now you have finished working through these. Again, if you press play or forgot to press pause, please do that. Get work through these problems. But I'm going to move on to the next slide with all the answers. So here are the answers. Notice again, I stuck with the letter P in number 7, N in number 8, and R in number 10. But it's fine if you use the letter Q. Fine if you use the letter X. Some students worry that if they don't write their answers in the same order that I have them, that means they're wrong. The order does not matter. So for instance, in number 7, if you wrote negative 4 and then 6, that is perfectly okay. So again, check each of your answers. And if you missed any, see if you can go back and figure out what you did wrong. And then please, please, please reach out to me. I love to do Google Meets with you guys and work through questions. I promise I won't keep you long, just for whatever you need support on. All right, I'm going to move on to the next slide. If you need more time for checking, again, please press pause. So that finishes up our lesson for today. Your homework for this week is there is a quiz in Canvas called Solving Quadratics. I think there are 13 questions, if I remember correctly. I think that's right. Something similar to that, so not super long. Again, make sure you watch the videos from weeks 1 through 3 and take in your quizzes in Canvas. There are 7-1 to 7-4, 7-5 to 7-8, and then there's factoring quiz number 1 and number 2. So that covers the first 3 weeks of remote learning. Some of you still have not started. And then grades are closing this week. They're finally going to finalize quarter 3. Some of you still have not reached out to me about completing that chapter or unit 6 test or quiz. A couple of you still had not completed those, so please let me know what or when you're ready to do those, because I believe, again, I think it's Wednesday that Coach Bunting said that they're going to cut off grades for 3rd quarter. So please, please, please get that done. Hope you guys have a great week. Please reach out. My email address is there, and I hope everyone's well. Take care. Bye.